Hello, I'm Peyton Owen. This is Physics 2111 Lab 4 about springs and motion of springs. So the purpose of this lab was to just kind of see what spring force looks like using a video either that we can take or provided to us by the physics department. And by using that video and tracking it, we can make our own simulation of spring force in GlowScript, um, which can help us further understand spring forces and how they interact with masses. So just kind of a little overview of what's going on here. We're going to go look at the fundamental physics behind everything, a preview of the final results, some of the code, some of the data, quick little recap, and then some sources of error. So fundamental physics, force equals mass times acceleration. That's Newton's second law. Energy principle. Energy is equal to force times position. And then the spring force, F equals negative K, L minus L naught, L hat. Pretty simple stuff. Just, yeah. And this was the preview. I'm going to focus a lot here about mostly the motion here. It kind of looks like a little grid, but that was towards the end of the simulation. So what it's really doing is it's starting at one point and it's making that grid by following one line. That's all one line. And you can kind of see here how it repeats a lot, and that looks like a repeating pattern. So here you can see that as delta U grav, so as the energy of gravity decreases, the kinetic energy will go up, and then as it's increasing, it'll go down. But also that the spring force is directly opposed to gravity. So whenever it's stretched out all the way, whenever gravity would have been acting on it the most and now the least, the spring force would be the most. And then whenever the spring pulls it all the way back, and it's at the top, then the gravity would be the most. And you can kind of see that relationship. It's I think the word's sinusoidal, but this shows the simulation and a position over time graph with changing kinetic and gravitational energies. So yeah, but the most important thing to see is that the total energy does not change throughout the entire graph. Um, yeah. This is the code. A lot of the code that we had to mess with. Um, this obviously gravity's 9.8, but this was given in a video, and this was also given in a video. L, pretty easy. Ball position, my spring position. L hat, it's just L divided by the magnitude of L, whatever. Spring is magnitude of L minus L naught. Cool. K equals 1/2 times ball mass times magnitude of ball velocity squared. Gravity, that's the spring, and that's total energy. This is the initial energies down here, which can also be seen right here. And we can see that we actually update through these, or not update, we change them so that you can calculate energy through a loop. So while this is in the loop, your new energy, your new K, your new delta K, UG, delta UG, whatever is going to use your originals too. But let's focus on the gravitational force for a second. It's just vector gravity, no big deal, mass times gravity. Spring is going to be this, the spring stiffness times spring times L hat, no big deal. F net, there's only two things, spring and gravity. Yeah. Velocity is just your velocity update position, your position update. Ball position, my spring position, I'll give you L. L hat, same earlier. Spring axis, L. Trail, sure. Yeah, and pretty much does that for the important parts of the code. Where did the data come from? As I said, it was from the video they gave us. There's a mass on a spring right here. Here's some of your initial conditions that they also gave us. But system was spring and the mass attached to the spring, and then the surroundings were gravity slash Earth. And here's a recap. The main idea of this lab was to track a mass on a spring as it moved around being released from a certain height. We used that track data to create our own simulation in GlowScript, which showed us the relationships between all the forces and energies that are intertwined within the system. Possible sources of error would be like misclicking where the center of the mass was, or just a real bad error in the code. But I don't believe either of those occurred on this lab. So thank you very much.